Welcome to the video about sonification of the ternary 9-field signal. And here it is. And let's dive into some basics about it. There are three kinds of signals: a 1, a 2, and a 3. It's important to know. A 1 is symbolized in a long line, a 2 in a two-parted line, and a 3 in a three-parted line. Easy to understand first. And if we look in some basics about it, we can see the first line is consisting a 2, a 1, a 3, a 1, and a 2. Let's use some colors. If you use the same signal with colors, you can see a symmetry. The 2 is mirroring here the 2, the 1 is mirroring the 1, and the red 3 is mirroring the red, the blue 3. So we have always a mirror in this line. There is a symmetric. So this is the first thing we have to know about for the first line. Okay, we transcribed it for better visibility in these bigrams: a 2, a 1, a 2, a 1, a 3 and a 3, a 3 and a 3, and a 1 and a 2, and a 1 and a 2. So we have it the same line here in the music. Let's hear this signal as sonification, like I did it as composer. Okay, you can hear the symmetry: 2, 1, 3, 3, 1, 2. Here is the mirror. You can see this is a complete mirror. And let's look in the whole signal. So this was the first line: 2, 1, 3, 3, 1, 2. Then we have a second line and a third line. And so this is a whole 9-field. You can not see it in the first view that it is a 9-field, but I can count it: 1, 2, 3, 4, 5, 6, 7, 8, 9. So I did also transcribing it as bigrams, 9. And I transcribed it into music. As we heard the first line, I will repeat it. The second line sounds also like an answer. This is very, very, very unusual. Listen to the first line. It's like a question or a beginning of a melody, and this is the answer of this melody. Listen. Isn't it? And the third line seems to be a conclusion, like a question, an answer, and a conclusion. I tell it in the terms of a composer, of a musician, and a listener of music. If you are also an active listener of music, you can follow these thoughts, even you are not playing an instrument, or even you do. And you can try to play it on your piano. Only lose these three fingers. Very easy to play. And it's only 3 notes in the whole composition. So that's the sonification of this signal. And you see there is something symmetric inside. If you look at the whole picture, you can see that this is mirroring this, and this is really a mirror here. It's not quite so simple to see if you look at this. But in the music you can feel these connections. Let's start again. This was the first line. Let's go in the second. And go in the third. It's something that you can feel as in the music, as a melody, as a message, something that tells to you something. And let's get again transforming this into a left and a side colored part. It looks like this. We can see the left part is red and the right part is blue. Very easy to see the symmetric. And we can transform it also in numbers here. We transform the blue and the red in numbers. 2, 1, 3, 3, 3, 1, 2. And you can see here also the 1 and 3 is mirroring 3 and 1. Don't mix up with numbers. This is not 13 or 31. This is not 32 and this is not 23. It is a ternary number system. It's complete other kind of numbers. Yes. Now, if you use colors, you see the symmetric of the numbers. The numbers are really mirroring. There is a mirror. There is a symmetric inside. Yes, this is the transcription which I made here also in the 9 field. Again, the first line as numbers. So more I have also made analysis, which is very interesting because this signal has, or in this line, if you look concrete in the line, in the first line, you can see there is a that's why I use a big grams to visualize these triangles numbers. 2, 3, 1 in the first line, and in the second line 1, 3, 2. So I write it down as a triangle, and you can also listen to the triangle. The first line is a C, and here the first line is a D, and here is the first line a E. I play it. As you can see, this is a triangle of 3 tones. And the second line is here a E, a D, and a C. And if I play it together, it's again the triangle. So this mathematical order inside, you can make visible a sonification, as I did. So how much triangles are there different? I realized there are 6 kinds of triangles in this signal. 1, 2, 3, 1, 3, 2, 2, 3, 1, 3, 1, 2, 2, 1, 3. There is missing a 2 there. I will write it here. So a 2. And the 3, 1, the 3, 2, 1. As you see, nothing is perfect. These 6 kinds of triangles are inside, maybe in this kind of signal. So let's take the second line. Is there also a triangle? Okay, let's take the first line is a 1, the second line is a 2, and the third line is a 3. So we have a 1, 2, 3 triangle. Okay, for better understanding, if you can't follow my music explanations, I wrote here a triangle with the 1 line, with the 2 line, and the 3. And here see the transformation. 1 transforms in 2, into 3, and from the 3 in the 1 again. It's like in the music. 1, 2, 3, 1, 2, 3. So this is a 1, 2, 3 triangle. And you can even better understand it if you look here without the notes. 1, 2, 3. But in the second line, what's happening? It's symmetric. 1, 2, 3 in the other direction. 1, 2, 3. And if you listen to the musics, the sound of the lines, this line and this line and this line together, it's a triangle. And then if you take this and this and this together, so there is a rule. All these triangles consisting of a 1, a 2, and a 3 line, never repeating a number. It is never the 1 repeating or the 3 repeating or the 2. It's the theoretical conclusion about the signal. And let's analyze the third line. In the first line of the bigrams, you have a 3, a 1, and a 2. A 3, a 1, and a 2. This is a 3, 1, 2 triangle. Okay? And you see the second line of the bigram is a 2, 1, 3 triangle. Let's find it in my drawings. This is a 2, 1, 3 triangle. We have 6 kinds of triangles possible in the mathematical order. So let's also sonificate it. So I played this D, if here is a E, then there has to be a C, not a D or a E. It does not repeat. It has to fit together to a triangle. It's always a triangle. So, and now, the craziest thing of this is, the signal has in its 9 field also the same rule from which it has in the line from left to right, also from up to down in this direction, and also here, and also here. That's why I wrote it in a 9 field. The geometry allows not only to go in this direction to make analysis, it also in this direction. You see it? And this is important because this is complete right. The first is a 2, here is the first a 1 and the 3. So we have a 2, 1, 3 triangle. A 2, 1, 3 triangle. This is a 2, 1, 3 triangle, as you can see. Okay, then let's take the second line of the bigrams from up to down here. This is a 1, here is a 3, and here is a 2. A 1, 3, 2 triangle. How it looks? This is a 1, 3, 2 triangle. So this is for the better understanding. Let's also hear this. Okay, then let's play this, and this note together. This is a C. Together? Okay, it's the same sound. All together. And here, this. It's the same sound, triangle sound. We have, so they're not only in this direction, we have it also in this direction. And here fits it also. Here are 2 3s, here 2 2s, and 2 1s. I make it short. All together. So and let's prove the last column here. This is a 1, this is a 3, and this is a 2. A 1, 3, 2 triangle. A 1, 3, 2 triangle. Here you have it, a 1, 3, 2 triangle. And let's play the sounds. You can follow, I hope. This is a E, a D, and a C. And all together, it's the same sound. And here the last, here is a 2, a 2, a 1, and a 3. So it is a 2, 1, 3 triangle. It looks like that. A 2, 1, 3 triangle. 2, 1, 3. So all together, I listen to the music. 2, 1, 3. 2, 1, 3. The same triangle. So we have in all directions geometrical connections with the notes. This little sonification shows that the signal, it's from the novel of my uncle, who wrote it for children, a science fiction novel, and he used his scientific material, and I transformed it into music to make this a little bit interesting and easier to understand. Make it so, and the sound makes it also possible to make inspirations, to compose something new about this melody. And really, I have the impression this melody is really not only numbers. These are really a melodic connection. We can tell it, these notes are in two directions with each other and in a state of entanglement. You see, if here is a C, then here is a D, then has here to be a E. This is a rule. You cannot have a C or D in this position. It's impossible. This is the rule of the signal, and it works in this direction, also in this direction. So this, all the notes which you can hear, these 18 notes, are entangled music notes. And let's listen again. And I made some chords to it, so you can see how sonification also works. Let's start only with the melody, then we hear some accords, and then we simply hear again the melody at the end. So, thank you for watching this video and following my sonification of the ternary 9-field signal.